Thank you so much for joining this lesson. We're going to discuss mathematics paper 1, transformations. Number 9, we are told that the coordinates of a triangle ABC are A, 1, 1, B, 3, 1, and C, 1, 3. Part A, plot the triangle ABC. Remember to subscribe to this channel and to also share the link with friends. The number attached here can be used for consultations, and if you are interested on individualized tuitions, use the same number to register your request. Okay, I want to mention this. I've already drawn the axis with a scale already, with a scale of 1 centimeter for 1 unit. But it is good to know that this is the recommended scale for this topic. If not so, let the scale chosen for the y-axis be also the same scale for the x-axis. Take that precaution kindly. This is to mean that sometimes for a regular shape like a square, if you use a scale which is different for the different axes, you will end up changing the shape of a square to maybe a rectangle or something else. So it's recommended to have a uniform scale. Let me plot the triangle now. Coordinates of A, 1, 1. So we're going to have 1, 1. This is where our A is. Then the next, B, is a 3, 1. So 3, 1. This is where B is. We also have the coordinate of C as 1, 3. So 1, 3. In other words, we are just looking for the intersection of x equals to 1 and y equals to 3. That intersection gives us the coordinate. If it is 1, 1, then the intersection of x equals to 1 and y equals to 1, they give us A. The intersection of x equals to 3 for B and y equals to 1, the intersection is here, we get the coordinate B. So now with the plotted coordinates, we can get the figure by joining all the vertices now, because they have already been plotted. Remember to share this link with your classmates, with your friends and relatives. Now, after drawing the triangle that way, allow me call it the first triangle now. That is the first triangle. Now we are told in part B, the triangle ABC undergoes a translation vector 2, 2. So this is a translation vector 2, 2. Obtain the image of A prime, B prime, C prime under the transformation. Then write the coordinates of A prime, B prime, C prime. So we're going to perform a translation, and the vector is 2, 2. The vector is 2, 2. Therefore, we can get the image of this triangle. So if we are saying the vector is 2, 2, it should be known that we are going to translate or move 2 units in the x-axis, that means to the right, and also positive 2 units on the y-axis, and that means upwards. So that is how we're going to perform the translation. So for us to get the image of A, then we have to move 1, 2, then also 2 units upwards, 1, 2. So this is where we're going to find the image of A. We do the same for B. We move 1, 2, then upwards, 1, 2. So B is going to be found here, B prime. Then finally we have C. We also move for C, 1, 2, then 1, 2 upwards. This is where the image is C. The image of C is going to be. Now with the plotted coordinates, we can join them to get the triangle, which is the image of the first one. So we again join the vertices. Now we have performed a translation following a translation vector 2, 2. Now with this, the examiner is demanding we list the coordinates of A prime, B prime, C prime. So A prime is going to be 3, 3. C prime, we can just have B, that order, B prime. So B is going to be, this is a 5, 3. And finally, C prime is going to be, now C prime is going to be 3, 5. 3, 5. So that is the coordinates. This one, allow me call it the second triangle. We proceed to part C, whereby we are told that A prime, B prime, C prime undergoes a reflection along the line x equals to 0. Obtain the coordinates and plot on the graph points A double prime, B double prime, C double prime under the transformation for 2 marks. So the first thing will be obtaining the coordinates. When we are doing a reflection along the line x equals to 0, it first of all has to be known that x equals to 0 is also equivalent to the y-axis, because we have the lines which are named in terms of x along the x-axis. This is point x equals to 1, x equals to 2, x equals to 3. Therefore, along this point where the value of x is 0, then the line which can be drawn there is the line which is equivalent to the y-axis. So when you hear the mentioning of x equals to 0, then we mean the y-axis. Now we are going to reflect the second triangle so that you may get the third one along the vertical axis, which means we just join using a very straight line. We just join point A to the mirror line, point A to the mirror line using a very straight line, then which of course will be perpendicular to the mirror line. Then along the same line, now we move an equal number of units to the opposite side. So when we reflect A, because it is from the mirror line 3 units, now we move again 3 units on the opposite side of the mirror line. Therefore, the second image of A is going to be here. That's why we are calling it A double prime. We also do the same for B. So we join B to the mirror line through a perpendicular line. Then we move along the same perpendicular line an equal number of units from the mirror line to B prime. We take them now to the other side, an equal number of images. So because equal number of units, so because these are 5 units, now we also move 5 more units again to the other side, and this is going to be our B double prime. Then we can also talk about C. When we join C to the mirror line following the perpendicular line here, then we can see it is 3 centimeters away. Therefore, the image of that point is also going to be 3 centimeters away, but on the opposite side. So that is what we call a reflection. Now we have reflected this triangle along the mirror line here to this side. So this is going to be C double prime. And now with the plotted coordinates, we can get the triangle. So let's get the triangle by simply joining the plotted coordinates. We plot the triangle now. Remember, we were to get the coordinates, so we have to mention them after identifying, obtain the coordinates. We have now obtained the coordinates. We have drawn the third triangle, and we are supposed now to extract the coordinates. Therefore, the coordinates of A double prime are going to be -3, +3. -3, +3. There is B double prime. This is going to be -5, +3. Then finally, we have C double prime. So for C double prime, we have -3, +5. So -3, +5. So now we are having the second image, which is triangle 3. We proceed to question part D. We are told this, the triangle, which is the second image, undergoes an enlargement, scale factor -1, center origin. The most important things when describing a transformation, which is an enlargement, is usually the center of enlargement and also the scale factor of enlargement. So now we join. Remember, the enlargement will be happening with the center origin, which is coordinate 0, 0. Origin is 0, 0. That is the coordinate of the center. Now we are going to join our coordinates to the center. The scale factor is -1. So now when we join to the center, allow me use a different, so we join this now to the center, then we move to the other side. Reason as to why I'm moving to the other side is because the scale factor is negative. Now when the scale factor is negative and we have a center here, then if the object is on this point, the image will be on the opposite side of the center. So if it will be on the opposite side of the center, it means, again, the value of the scale factor, remember in this case we have a -1. So the negative tells us that it will be on the opposite side, and the value here tells us how it will be magnified. If it is 1, how it will be enlarged, sorry. So if it's 1, now we are only going to move just once, an equal distance on the opposite side. So standing at the center of enlargement, I'm going to lift the distance to where A is, and because the scale factor is negative, I mark this distance on the opposite side, and because the scale factor is only 1 unit, now it's going to be only once, just once. If the scale factor was -2, then we would have marked 1, and we stand on that mark and we measure again an equal distance. But now we just have to indicate that this is our A, third image. Then now we repeat the same for C, we repeat the same for B, until we fully enlarge using -1 center origin. So now I'm going to join C to the center, then I move to the opposite side. Therefore, I'm joined to the center and I'm now moving to the opposite side. That means now I'm just going to stand at the center, then I lift the distance all the way to C, then I transfer it to the other side because I'm supposed to move just once. So this is where we're going to have our C triple prime. That is where C is. And finally, we talk about B, whereby B has to be joined to the center. B has to be joined to the center. Then I move to the opposite side along the same line to the opposite side. So standing at the center, I lift the distance to where B is, then I transfer it to the opposite side. Remember, the opposite side is because of the negative scale factor, and moving once is due to the value which is on the 1. So we are enlarging using a scale factor 1. So this is now going to be B, the third image of B. The third image of B, and now we can get our complete triangle after the enlargement. Complete triangle after the enlargement. So now we are having the fourth triangle. The fourth triangle. That is the fourth triangle. And finally, because we are continuing with the question, there is a part E, which says that the triangle ABC, the third image, undergoes a rotation, center 1, -2, angle 120. This means now when we join each point to the center, then we are having a positive angle of 120. Then we shall move, or we shall rotate in the anti-clockwise direction. Therefore, because it is positive, it's going to be anti-clockwise. The direction, the angle, and the center of rotation describes such a transformation. So never rotate until you understand the angle, the center, and the direction, which is anti-clockwise in this case. So center is a 1, -2. So now we'll be using center 1, -2. Center 1, -2. So this is going to be our center. It's going to be our center. Now with the identified center, now we need to join. If it is C, we join C to the center. We join C to the center. Then we just move on the opposite side a little bit so that I may use my protractor to measure the angle of rotation of 120 in the anti-clockwise direction, because it is a positive angle. So now I'm going to place my protractor at this point. Then once I place it there, now I will have to consider the angle of 120 in the direction which is the anti-clockwise, and this is where the angle is. This is 120 in the anti-clockwise direction. So from this point through an angle of 120, I will have rotated. So now I'm going to move along that line where the angle of 120 is. So that is through an angle of 120. But now the distance has to be equal. The distance has to be equal. Therefore, I will stand at the center. Then I pick the distance of C. And along that angle now, I mark. Inside that angle, I mark. If it is C, the one I've started with, now this is going to be the coordinate of C. The coordinate of C, the fourth image. We do the same for point B and A. Therefore, I can join point A to the center. I join A to the center. Then I move a little bit so that I may place now my protractor so well. So I'll be placing the protractor here. Then I move. through an angle of 120, whereby I'll find myself here through an angle of 120. Then now I produce that line. I produce this line. Then something I should remember is that the distance is going to be the same. So after producing that line to indicate 120 degrees, now I have to stand at the center with my compass and lift the distance to point A. Then I transfer it to this point. Therefore, it means the fourth image of A is going to be here. The fourth image of A. So A, the fourth image. And finally, I do the same for C. So I join, the last one is B. We started with C. So when I join B to the center, using a very straight line, center of rotation, now I have to move again a little bit just to ensure that I can have a base for my protractor. So now I place my protractor at the center using the line from B. Then now I measure 120. That is where 120 is in the anti-clockwise direction. Now I'm going to use a ruler to connect the angle of 120 to the center, so that when I will be moving using a compass from the center to B, then I transfer the distance to such a line. I transfer the distance here. That is where the distance is. I'm going to have that one as my B. So this is going to be B. B for the image. Then now we can do the diagram now. The complete diagram can now be completed. So A, B, C. So this is where C is. That is where C is. Then we have B at this point. Then we connect finally here. Now this is our fifth triangle. This is the fifth triangle. Fifth triangle. Now with that, we can write the final question. Which triangles are directly congruent? We are supposed to know when we talk about congruence, first of all, we mean a triangle or a figure and its shape being equal in size and shape. Equal in size and shape, we say that they are directly congruent. We say that that is congruence. So congruence, let me just put down. Congruence, this one is when figures are equal in size and shape, and according to the triangles which we have here, all the figures are congruent. They are congruent. But now with congruence, there is direct congruence and opposite congruence. So when we say direct congruence, what do we mean? Direct congruence. Direct congruence. When we say direct congruence, now we mean that they are first of all equal in size and shape because they are basically congruent, but now they can fit into one another. The two figures can fit into one another, either directly or by tilting all the vertices through a common angle, through a common turn or angle in the same direction, through a common tilting all the vertices through a common angle or the same angle in the same direction. In the same direction. So if in case you tilt an image, it will fit back into the object, all the vertices through the same direction following the same angle. That is direct congruence. Or without even tilting, just fitting into one another directly, that is still direct congruence. But if they don't fit directly, and when you tilt in the same direction, they still don't fit, then that is opposite congruence. So the opposite of what we have described is opposite congruence. Precisely, we can say that directly congruence or direct congruence is a direct congruence. Still talking about direct congruence is where rotation and what we call translation. When translation is involved, what we get is a direct congruence. Let's consider the diagram now. We are talking about rotation and translation. Through the same, I'll also be showing a very interesting discovery about rotation. So we are saying, for example, in the first transformation we translated, that was the first triangle to the second one. That was a translation. So if you lift the first triangle direct into the second one, it will just fit. So when you just move this triangle, you move it into this one, you'll find C will fit into C prime, B will fit into B prime, and A will also fit into A prime. That means that triangle 1 and 2 are directly congruent. We are stating some features. So we can say A, B, C, together with the first image, they are directly congruent. Let's proceed. There is a rotation which has been involved here. So we were rotating the fourth triangle so that you may get the fifth triangle here. Therefore, when you move, when you lift triangle 4 into triangle 5, they will not fit directly. But in case you rotate, standing here, if you tilt A through a certain angle, you just tilt A until it fits onto its image. By the time A will be fitting into its image, then B will have moved into the image of B, and also C through the same angle will also fit into C. So that is something you should understand. 4 and 5, whereby rotation has been involved. When you lift 4 into 5, they will not fit directly. But if you tilt uniformly, you just tilt through a common angle, by the time A is fitting into A prime, then B will also fit into the image of B, C will also fit into the image of C. And that is why we say by a rotation, there is direct congruence. Therefore, the fourth triangle, which is the third image, this is this one, triple prime, and the last one, there is also direct congruence. Something else we should also understand now, as I wind up, is that there is an enlargement which was involved. That enlargement was to a scale factor of -1, whereby if it is A, after joining to the center, we went to A, an equal distance on the opposite side. So I want you to discover that if that was an enlargement, scale factor -1, but if we were rotating through a positive 180 or a -180, we would still have gone to the same point. If you join A to the center, then you move through 180 and move an equal distance, that is a rotation through positive 180, you will still come to the same point. If you join A to the center and you move through a positive 180 or -180, you will still come to the same point and move an equal distance. Therefore, we can say enlarging using a scale factor of -1 is just the same as a rotation. Just the same as a rotation through positive 180 or through -180. And they give us the same object. So even though it was an enlargement, this one now becomes a special case. An enlargement of scale factor -1 is the same as a rotation of positive 180 or -180, and so the transformation involved there is now giving us direct congruence. Direct congruence because if we move C, let's consider even B. Yeah, can consider even B. So if we move, standing at this point, we move point B through a certain angle until it fits. We are tilting B until it fits onto the image here. By the time B is fitting into B, C will have moved through the same angle and it will fit into C. Then A will still have moved through the same turn and it will fit into the image of A. And so you discover that enlargement scale factor -1 is the same as a rotation. And so we get a direct congruence. So we can say the third triangle here, which is the second image, together with the fourth, are also directly congruent. Therefore, triangle A, B, C, together with the third one, B, C, is also another pair of directly congruent figures. With a reflection, it is opposite congruence. Do you know why? There was a reflection here. In case we lift this second triangle to the third one, they will not fit into one another. You see, if you bring here, they will not fit because of how they are facing. And if you try to rotate, remember, by the time you bring them, this is how they shall behave. C will be up there. This is where C will be. Then A is the one which will be here, and B will be here. So we will get such a triangle. So if you lift this one into this, that's how they will fit into one another, not directly. And if you try to rotate, by the time you are bringing C here, you will discover that this is B. It will have moved beyond. And point A will also move, if you are moving it through, let's say, a clockwise rotation. So if you try to rotate C into C, this A will move to somewhere up here. This B, sorry, will move to somewhere up here. And A will have moved to this direction again, because this point will also have to move. So A will have moved, and this B will also rotate through the same. Meaning that there is no way the three vertices will fit into one another at the same time. So that is an opposite congruence. Thank you so much for following. Subscribe and share.